Client-server architecture. Client-server architecture is widely used software architecture pattern in which client applications request resources and services stored on a server. This model divides the workload between the providers of a resource or service known as servers and the requesters known as clients. Clients initiate communication sessions with servers which await incoming requests. Now, what are different components of a client server architecture? The first is the client. The client is the front end application that users interact with. It sends the request to the server and displays the response it receives. Clients can be desktop applications, mobile apps, or web browsers. Next, server. The server is the backend system that provides resources, data, and services. Servers can handle client requests by performing the required operations and then sending the results back to the client. Next, network. The communication infrastructure that allows clients and servers to exchange information, typically over the internet or an intranet. Now, what are the benefits of a client server architecture? First, centralized management. Since resources and data management are centralized on the servers, it simplifies administration and updates. Scalability. It's easier to scale the backend independently of the client, handling more requests by upgrading server capabilities or adding more servers. Efficiency. Resources are utilized only when necessary, and the distribution of tasks can be managed dynamically based on demand. Security. Centralized control over data and resources enhances the security measures as they are implemented on the server side. Let's move to the drawbacks. First, network dependency. The performance largely depends on the network. Poor network connection can lead to delays or failures in client server communication. We have server overload. The server can become a bottleneck if too many clients send requests simultaneously. And then we have maintenance cost. High quality servers and their maintenance can be costly. Upgrading and securing servers also add to the expense. Let's look at an example of an online banking application. Now, in this particular case, we have the client, which is a user's browser or mobile banking app that sends requests to check balances, make transfers, and pay bills. The server is the banking system's server processes these. The banking system's server processes these requests, performs transactions, updates accounts, and sends back confirmation details. Then we have the network, which is the internet, which facilitates the communication between the banking app and the banking servers. Let's look at a real world analogy with the restaurants. A restaurant operates in a client server model where diners, which are the clients, request meals and the kitchen, which is a server, prepares and provides the meals. The waiter or waitress acts as the communication link, which is the network between the diners and the kitchen. Some of the popular use cases for this particular architecture is web applications, websites where the client, the browser, interacts with the server, hosting the website content and functionality. We have email systems where clients, which are the email apps, connect to a server to send, receive, and store emails. We have database applications where client access a database server to query, update, and manage data. Now, the client server architecture is foundational for many types of applications, especially those involving a clear distinction between user interface and data processing. It provides a robust framework for building scalable, manageable, and efficient software systems suitable for environments ranging from small scale applications to enterprise level solutions. If you have any questions on client server architecture, please leave them in the comments.